Alright, hello Algebra 1 Part 1. Seems like this chapter's going on forever. We have 2 more sections left in Chapter 5. So here's what's going to happen. So today you're just going to have to watch this video, answer a little Google form for your attendance. Then Monday you'll have an assignment on 511. Tuesday you'll learn 512 with a video, Google form. Wednesday you'll have an assignment on 512, excuse me. And then I think Thursday we'll have a quiz on 511 and 512, and that'll be our end of Chapter 5. Then we'll move on to Chapter 6 after that. Alright? So, we're going to have 511, 512, and a quiz. That'll be just the unit of 511, 512, and that'll be it. Alright? So 511 is called Using Several Methods of Factoring. So over the course of the last test we just took, there were 4 methods of factoring we learned. We learned factoring those like where it's x squared plus something x plus 5. With all the different signs. We learned factoring by grouping, and we learned when we had something greater than 1, how we factor that. Okay, so we learned all different, and we learned difference of squares also before that. When we learned the perfect square trinomial. So we learned a lot of factoring throughout this chapter. And the reason it's so long and so much because it's super important to algebra. All right, so now today we're actually going to have a bunch of different problems. They're going to be 2 steps, and we're going to see that we're going to use all those different types of factoring methods. We have to recognize which one we're going to use. Alright, so the directions are just going to be factor fully, and we're going to see what that means, because there's going to be 2 steps to all of these problems. Alright? Alright, so let's start out with the first one here, okay? So let's say I get 10a squared minus 15ab squared. The first step I want to do for all of these problems is to find my greatest common factor and take it out of each term first. So that's going to be my first step of all these problems. So if I found the GCF, I'm not going to go through that. We know how to find the GCF, okay? If you have any questions on that, please email me. But the first off, I'm going to find my GCF. My GCF here between 10 and 15 will be 5 and also the A. So what I'm going to do now is I'm going to take out 5A from each of these terms. So 10 divided by 5 is 2. Take away an A, I have 1A left. Alright. Then negative 15 divided by 5 is negative 3. Take away an A, I still have 2 B's left. Once I take out my GCF, I look in here. Okay, well the only time when I factor when I have 2 terms and a minus sign is difference of squares. Well, 2 and A are not perfect squares. The B squared is, but the 3 is not. Since I don't have 2 perfect squares here, this is where I'm going to end. So I'm usually will end at this point. So I took out my GCF, and I can't factor what's in the parentheses anymore, so that's it. Alright, some of them will be as simple as that. Alright, let's look at a second one. Okay. Let's say I get negative 4x minus 6x squared. Okay, so first step, find my GCF. Alright, my GCF is, in this case, if I were to find GCF here, it would be negative 2x. Alright, so I'm going to take a negative 2x out of each one. So negative 4 divided by negative 2 is positive 2. Take away an x, there's no x's left. Negative 6 divided by negative 2 is positive 3. Take away an x, there's 1x left. That's it. If I look in here, I cannot factor what's in the parentheses anymore, so that's done. That's not going to happen every time. These are just very simple ones. It's like the simplest form of factoring. It's just taking the greatest common factor out, okay? We're going to do 8 of these, all right? So a bunch of examples. Those are the first 2. All right, so those are like the easiest problems. Just take the greatest common factor out, and I can't factor anymore. That's fully factored. All right, so let's look at a third one here. Let's say I get t to the third minus 9t. Alright? So, my greatest common factor here, let's take that out first, is just going to be t. They're not going to have any numbers common. This is just a 1. This is 3 and 3. They don't have any numbers in common, but they do have at least a t. So what I'm going to do is take a t out of each one. So here I'd be left with, I'm going to take a 1t away, I have t squared. Take away t away from there, I have 9 left. Alright, now I look in here. If you remember, when I had 2 perfect squares subtracted from each other, that's called difference of squares. I would go back in your notes or look up, again, or email me if you don't remember what difference of squares is. But remember, when you factor difference of squares, this is why it's so important to remember what we learned before, because it builds on each other. Difference of squares, you have two parentheses. It's the square root of the first number plus or minus the square root of the second number. So there it's fully factored. So first I took my greatest common factor out. Then I saw difference of squares on the inside, t squared minus 9. This is a perfect square, this is a perfect square, subtraction. So my factoring, this fully factored is t plus 3, t minus 3. Again, if I FOIL this back out, I'll end up with t squared minus 9. Again, this is the difference of squares. So that's two perfect squares subtracted from each other. And that's how you factor that out. Square root of the first number plus minus the square root of the second number. I took the GCF out first, then looked in the parentheses, see if there's anything else to factor. In this case, there was, so I factored it out. So 2 steps. All they're going to be like that. Either they're going to be more factorable, or take the GCF out, or they're not going to be. All right. All right, so let's look at number 4 here. So let's say I get y to the 4th plus 6y to the 3rd plus 9y squared. All right, because of the 1 here in the front, they're not going to have any numbers in common. It's just going to have 1, 3, and 2, 3, and 3. These two have a 3 in common, but this one doesn't, so we can't take any numbers out. But they all have at least how many y's? The lowest power of y in common is 2 y's. So my GCF here is no number, but just y squared. So what I'm going to do is I'm going to take a y squared out, and I'll have left a y squared, a 6y, right? Take away 2 y's, 1 y left. Take away 2 y's, I have no y left. Now you can either see if this is a perfect square trinomial, or you figure out two numbers that multiply to get 9 and add to get 6, like we did in 5, 7. So when I do that, I keep the y squared on the outside. Always leave your GCF on the outside, so I left the t out there. Then there's going to be two parentheses, right? It's going to be y. And then I have 2 plus signs. Think about two numbers that multiply to get 9 and add to get 6. What are they? 3 and 3, right? 3 times 3 is 6, and 3 plus 3 is 9. My final answer. If I multiply y plus 3 times y plus 3, I'll end up with this, and then multiply y squared out. And if I multiply this and then multiply this back through, I should end up with my original problem up here. So again, took the GCF out, saw what's inside here, so I had to figure out what method I'm using to factor it. In this case, it was difference of squares. In this case, I could have figured out it was a perfect square trinomial, or I could just figure out two numbers that multiply to get 9 and to get 6, and I factored it out. So 2 steps, yeah. But again, it's going to combine all the different factoring methods we've learned, so just know that. All right, so let's look at number 5 here. All right. So number 5, we have, sorry if I got in the way. So let's say I have p to the 3rd plus 2p squared plus p. Okay, if we look, they don't have any numbers in common, right? This is 1, 1, 2, and 1, but it's prime. So there's no number that come out, but they all have at least one p, right? That's the lowest power of what they have in common, p. So I'm going to take out a p from each one. So when I do that, I take away 1p, I have p squared left. Take away a p, I have just 2p. And then I have just, when I do p by p, if it goes away, it's just still a 1 there. So if I take away everything, it's just still a 1. Alright, so now I look in here. Well, I can factor, I've factored stuff like this before. It might not be factorable, let's check. I should have two numbers that multiply to get 1 and add to get 2. Well, the p stays on the outside. Let's see, let's try. The only way to multiply to get 1 would be 2 positives. Let's see, 1 times 1 is 1, 1 plus 1 is 2. Okay, we got it. The p, remember your GCF always stays on the outside, and I factored what was inside the parentheses. 2 steps. Take the GCF out, look at them parentheses, is it factorable? If it is, factor it. If it's not, you just leave it there. So in this case it was factorable, so we factored it. Alright. Alright, let's look at 6. So again, 6, I get u to the 3rd v minus uv squared. Okay, don't get confused. Let's find my GCF. So what's the lowest power of what we have in common? 1u and 1v, right? We have at least 1u and 1v in common. U to the first is the lower power of what they have in common. v to the first is the lower power, what they have in common. So I take out a uv, so I'm left with u squared, the v's gone. I take away a u, so I'm just left with v squared. Okay, well, two perfect squares, u squared is a perfect square, v squared is a perfect square. That's difference of squares like we did in number 3. So I leave the uv on the outside, that's uv, and then my difference of squares is the square root of the first number, so square root of u squared is just u, and then plus or minus the square root of the second number, which is just v. So again, 2 steps. Take the GCF out, look inside the parentheses. If it's factorable, figure out what type of factoring it is, and then factor it. In this case, difference of squares. In this case, just normal. I call it normal factoring. This is a special case, difference of squares. All right? All right, so just 2 more. Maybe like the hardest ones, I guess you could say, in some sense of the word. All right? So let's look at 7 and 8. Hopefully, I mean, again, it gets repetitive. As long as you know how to find the GCF and then you know how to factor, you're pretty much set. Which, again, tests are pretty good, so I think you all kind of know how to factor, which is good. All right, so number 7. So let's say you have 6u squared v, all right, minus 11u squared v squared minus 10u squared v to the third. All right? So if you were to find the greatest common factor, they actually have no numbers in common, okay, if you actually broke all the numbers down. But your GCF would be u squared v. They have at least 2 u's and at least 1 v. So I take u squared v out, what happens? So I take this whole thing actually away, so I just left with 6 minus, here I can take I take u squared away, so I'm just left with 1v. So I have 11v minus, the u squared goes away, so I have 10v squared. All right, well if you look, I know it's flipped from what we saw before, but I have a number greater than 1 in front of my v squared term here. So what that means is, remember we did this in 5-9, so if you go back to your 5-9 stuff, what I'm going to do is that A, B, C thing I did and factor by grouping. So A is 6, B is negative 11, and C is negative 10. So I do AC is, so the U toward V, so it'll be there, it's going to be negative 60, and B is going to be negative 11. So I need to figure out 2 numbers that multiply to get negative 60, and add to get negative 11. If I went through my factors, this would be, negative 15 and 4. Negative 15 times 4 is negative 60. Negative 15 plus 4 is negative 11. So again, I'm going to actually leave this on the outside right now. I'm actually going to factor this, okay? So remember, I rewrite the first number, rewrite the middle as negative 15v plus 4v, and then I have negative 10v squared at the end. So remember, I turn that into 4 terms, all right? So remember, rewrite the first and last number like we did in 5-9, and rewrite the middle as negative 15 and 4. Remember, it was just the flipped way around. It was the v squared in the front. So now I'm going to group the first 2 and the last 2, right? Here, 6 and negative 15v, my GCF is 3. When I have that, I'm left with 2 minus 5v. In the second set of parentheses here, they have a 2 in common, also a v. So I'd be left with 4 divided by 2, and the v weighs 2. Negative 10 divided by 2 is negative 5. 1v left. These are the same, that's what I want. So my final answer is going to be, I'm going to have the u squared v, don't forget about that on the outside. I'm going to have 2 sets of parentheses. I'm going to have the 3 and a positive 2v and 1. So it's a positive 2v and a 3, my GCFs I took out there. And then, so 3 plus 2v, let me rewrite that. Again, a lot of you guys got these right on the quiz test, you guys must know what you're doing, so that's great. So 3 plus 2v, if not, you better learn because this is going to be important, especially if we come back to school, you're going to do this in front of me in person. Then you also have 2 minus 5v as the other parenthesis. That's your answer. Take the GCF out, look what's inside. In this case, this is what we did in 5-9. Number greater than 1 in front of the squared term, so you have to factor it by grouping. Alright, so a little bit trickier. All right, last but not least, we have one more. Again, these are like the hardest ones you'll see, basically. All right, so let's do this last one. That's it for the day. Alrighty. So, number 8. Let's say you get 2u to the 5th minus 7u to the 3rd Actually, let's make this, sorry, let me change this really quick. So 2u to the 4th minus 7u to the 3rd minus 4u squared. Alright? So let's factor this. So they all don't have a number in common, but they all have at least 2 u's, right? So I'm taking out a u squared. So I'm left with 2u squared minus 7u minus 4. Alright, so now let's see if we can factor this inside. So remember, we have a number greater than 1 in front of u squared, so we're going to factor by grouping. So a is 2, b is negative 7, just like we did in the last problem. C is negative 4. So I get AC is negative 6, right? 2 times negative 8, sorry. 2 times negative 4 is negative 8. B is negative 7. I need two numbers that multiply to get negative 8 and add to get negative 7. If there's none of those, then it's not factorable. Let's see. Let's try, what is that? Negative 8 and 1, right? Negative 8 times 1 is negative 8. Negative 8 plus 1 is negative 7. We got it. So remember to factor this. I'm going to do this to the side now. I'm going to have 2u squared, rewrite the first number. Then I'm going to have negative 8u plus 1u, all right? And then minus 4. Then I group, remember, turn into 4 terms. So here I can take, my GCF is 2u, so I'd be left with u minus 8, u minus 4, sorry. And it looks like I already have that here, 1u minus 4. But if I have that already, I can just take out a 1. So again, if this is already what this needs to be, right, if you know this GCF is right, remember these need to be the same, just take out a 1. Then I have u minus 4. So these two are the same. I just look at a 1 there. So my final answer here, I'm going to leave the u squared, the GCF here. The GCF was u squared, right? So I leave that u squared out in the front, and then I have 2 sets of parentheses. I have the 2u and the plus 1 are one of them, and the u minus 4 is the other one. So again, you find the GCF of the original problem, take it out. Look in the parentheses. Is it factorable? If it is, factor it whatever way you can. Difference of squares, perfect square trinomials, factoring by grouping, so on and so forth. And then you're done. Remember to leave the GCF on the outside, the original GCF you took out, and then whatever you have factored out, that's how you factor it fully. Just taking the GCF out is not going to suffice. Alright? Alright guys, so that is 511. So again, we have one more section we're actually going to use this to solve. If you have any questions, please feel free to email me, and have a nice weekend. I'll see you guys Monday.